So in the previous video, we talked about null and alternative hypotheses, and we were kind of talking about this question that we did in the very beginning, which was basically I have this deck of cards, half of them are red and half of them are black, and we were trying to prove whether the proportion was equal to 50%. Okay, so the proportion of cards that are black and red. So what we did, we talked about null and alternative hypotheses. So we were saying that this is basically going to be my null hypothesis. And I wanted to know whether this was really 50% or not. Okay, so we also have an alternative to kind of decide, okay, it's either going to be this one or it's either going to be the other thing. Okay, so we talked about that. So when we think about null and alternative hypotheses, what did we do after we set our claim, I guess? So what we did then, after we said, okay, P is equal to 0.5, we gathered data. Okay, we started gathering data, and based on the data that we gathered, we wanted to say, is this really possible? Okay, is this unusual to occur? Okay, so that's basically what we're going to do now. So we set up our null and alternative hypothesis, which is what we did. The next step after our null and alternative hypothesis is to gather data. Okay, so the next step is gather data. And the data collection part is the most useful. It takes the longest, I think, because you need to go survey, you need to go experiment, do whatever you got to do. So we need to test if the null hypothesis is correct, or which hypothesis is correct. So we need to test which hypothesis is, and let me put in quotation marks, correct, because there's a way that we gotta do it. Okay, so so what we want to do is like, okay, let's go ahead and test it and see if the data is likely to occur. So we want to find the likelihood of the data occurring if the null is true. So if we know that the cards are really 50-50, what is the likelihood of me obtaining this data, this unusual data? Okay, so how are we going to collect this data? Well, we're going to collect this data, and what we're going to do is we're going to try to make it into, or compress it into, one single number. Because if I collect a whole bunch of data, notice here in my tally that I was doing, this is basically my data. Now, how do I know that this was possible or not? Well, many of you guys were thinking of the likelihood. How likely was this to occur? Okay, now one way that I can think about the likelihood or whether this thing is unusual or not, well, what have we learned in class that tells us whether something is unusual? Well, z-scores. Okay, z-scores tell you whether something is unusual. So if I can convert this entire data into z-scores, I can see whether something is going to be unusual or not. Okay, so and the way that we write it, we're gonna call them z-scores, but there's a special name when we talked about them in hypothesis testing. These are what we call test statistics. Okay, so you can think about these as z-scores. So this is just a statistic calculated from data that is used as a basis for deciding whether the null should be rejected. Okay, so basically the test statistic or test statistics is a statistic calculated from the data that is used as a basis for deciding whether the null should be rejected. So the way that we're going to do this is basically the test statistic is going to be my z-score. Okay, and if you remember how we calculate z-scores, A z-score is calculated the following way. So a z-score is just calculated by the mean. Oh, that's wrong. Taking the observation, subtracting the mean, and dividing it by the standard deviation. Okay, that's basically what the test statistic would look like. This is a z-score. Z-score is just a test statistic. Now, in this case, what are we looking for? We're looking for proportion. So for proportions, my observation, okay, is p hat. That's my observation. Okay, so the way that we're going to do it is that z is equal to p hat minus the mean of p hat divided by the standard deviation of p hat. Okay, now luckily in the other section in central limit theorem, we know what these guys are. This is going to be p hat minus the mean of p hat is going to be just p divided by the standard deviation of p hat, which is just square root of p 1 minus p over n. Okay, so basically the test statistic for proportions, and this is something that you want to know, test statistic for proportions is going to be z is equal to p hat minus p divided by square root of p 1 minus p divided by n. That is my test statistic. So basically, when I gather my data, I'm going to convert it into one number. So let me give you an example of what exactly this looks like. Okay, so here's an example. So suppose you are testing, okay, the following. So here's my null, p equals 0.5, and p is not equal to 0.5. Okay, so basically maybe this is the card. We said that p, the proportion of cards is just 50-50. And then the alternative is saying the proportion of cards is not 50-50. So this is maybe something that was given to us. This is what we want to find. Find the test statistic if out of 30 sampled cards, we got, I don't know, 10 black. So let's say we got that. So find the test statistic if out of 30 sampled cards, we got 10 black. Okay, so since we want to find the test statistic, here is the formula. Okay, so we're just going to ignore the HO and the HA for now. So Z in this case is going to be equal to P hat minus P divided by square root of P 1 minus P over N. Okay, so that's my formula for the test statistic. Okay, so you're going to find the Z-score of this. So now P hat in this case, P hat is going to be what we got. We got 10 out of the 30. So that's going to be 10 out of 30. That's my P hat. Minus P. What is P? Well, P is equal to 0.5. Divided by the square root of 0.5. 1 minus 0.5. Divided by N. N is the total number of sampled cards. Okay, this is 30. Okay, so what is this going to give me? Okay, so let's go ahead and put it in our calculator. Okay, so put it in your calculator and I end up getting negative 1.83, around that number. Okay, so basically this is my z-score. My z-score is negative 1.83. Okay, so what this means, if you remember from z-scores, we said that z-scores were unusual if they were greater than negative or less than negative 2 and greater than 2. So you can kind of tell that this is probably not as unusual. Okay, so I don't know if I can quite reject HO. Okay, it's not too unusual. It's still pretty okay. All right, so let's practice again. let's say we have another example, just so that we could practice finding test statistics. So suppose you are testing the following. So HO is P equals 0.30, and HA was that P is greater than 0.3. I don't know, something like that. Okay. If, I don't know, if P hat, let me just tell you what P hat was. If P hat was 0.5 with N equals 100, find the test statistic. Okay, so let's find the test statistic for this case. So we know that Z is equal to P hat minus P divided by square root of P, 1 minus P over N. P hat was already given to us. It was 0.5 minus P. P in this case is equal to this 0.3 divided by the square root of 0.3, 1 minus 0.3 divided by N, which is 100. Okay, so let's go into our calculator. And we're going to go ahead and put 0.5 minus 0.3 divided by the square root of 0.3 times 1 minus 0.3 divided by 100. And what I ended up getting was 4.36. Now at this point, you can kind of tell, whoa, that is a huge number. That is a huge z-score. And it's greater than 2. This is unusual. So already right off the bat, you can kind of tell, yeah, I'm probably not going to reject this guy. This guy is probably not true. Okay, this guy is probably the one that's true. And you can also kind of look at it. 0.5 is considerably much bigger than 0.3. How much bigger? Well, about 4.36 standard deviations. Okay, so now what we really want to do is that we want to check, okay, well, this guy, you can easily see it. This one for sure we're probably going to reject. We can say that this is not true. However, if I looked at this one, 1.83, well, I'm not sure if that is big or not. I don't know if I should reject or not. So how can we have something really concrete? Well, one thing that we can do is, what is the probability of this occurring? So how likely is it that I'll get a z-score of negative 0.83 or of 4.36? That's what we can kind of look for, okay? So what we really want to find out is how likely is this to occur, okay? So, and that's what we call the p-value, okay? And the p-value is basically the probability of obtaining a result at least as extreme if the null is true. So it's such a mouthful. It's a lot of big definition. So the probability of obtaining a result at least as extreme as basically the one that you got if the null is true. So what is the probability of getting this extreme value assuming that this guy is true? Okay, so if the p-value is very, very small, then you can probably imagine that then HO is really not true. Okay, so how do you really find this guy? So how do you find it? Well, the way that you find it is really easy. It's just normal CDF, which we've talked about many different times already. Okay, and the way that you're going to do it is the following way. This is how you find the p-value. So here is where it comes from. So it depends on what your alternative is. If you see that p is less than a number, then your normal curve, remember, is so the number, so you're going to have here, this is going to be your z value, whatever you calculated. You're going to look for all of this area. The area here is going to be your p-value. Okay. If your HA is P is greater than a number, then your p-value is going to be over here. Once you calculated your z-value, this is going to be your p-value. Okay? And if your HA is that P is not equal to a number, then your p-value is going to be on both sides, here and here. So you have two z-values. So basically what you're going to do is find one p-value. The p-value is going to be multiplied by 2. Okay, because you have two of these guys. Now you kind of see why this is called. So see how this is on the left? This is called left-tailed or left-sided. I think I said left-sided last time. So this is left-sided because it's on the left. This is called right-sided because it's on the right. And this one is called two-sided or two-tailed because it's on both sides. Okay, so we have all of this. Now, how small? Okay, you're wondering how small should it be? Okay, so we know that we're gonna find this p-value. We're gonna use normal CDF, and we're gonna try to find whatever this p-value thing is. Okay. Now the question here is, how do I know I'm gonna reject? How do I know what's small? Okay, so the way that we do it is, if the p-value is small, we will reject. Okay, so basically, how small do we want it? Okay, so how small? Okay, and what we're going to say, it has to be smaller than the significance level. Smaller than the significance level. Okay, so let me just tell you what the significance level is. So the significance level is going to look kind of like a fish. It's called alpha. Okay, this is usually a threshold. Okay, this is given to you, given in a problem. So I will tell you what the threshold is. Okay, and this is basically the probability of rejecting the null. And later on, we will go a little bit more in detail of what exactly this is doing, what this alpha is doing. Okay, so the rule of thumb, so here's my rule. My rule is, if the p-value is lower than alpha, then reject. Okay, so if it is lower than alpha, then reject. If not, we fail to reject. Okay. All right. So that's basically the rule of thumb. Okay, that's how we're going to reject and not fail to reject. Okay, so in the next video, what we're going to do, I'm going to show you how do we calculate the p-value, because I gave you guys a lot of information. So I'll tell you how do we calculate a p-value. And then afterwards, we're going to put everything together into one problem. Okay, that way you can kind of, because I know that a lot of it is very loose and you're like, well, there's a lot of stuff that's going on. But I kind of wanted to give you guys a little bit of the basics.